Now in this problem here, we're given three matrices. We are given that A is a 2 by 4, B is a 3 by 2, and C is a 2 by 2. And we're asked which matrix products we can actually perform. Like for example, could we perform this product here, A times B? Well, look, A is a 2 by 4, B is a 3 by 2. These two do not match, so this product here, AB, cannot be done. What we need to look for is a column, right? A column that matches a row. So a column that matches a row. So a column of 4, there's no rows that start with a 4, so we can't have A to begin with. But what about this? All right, here's a column, a row and a column. This column matches that row, a 2 and a 2. So why don't we try BA? So let's write it, see what happens. If we try BA, get those sizes. B is a 3 by 2, A is a 2 by 4, and sure enough, these numbers are equal, so that product is acceptable. And then what about if we try, well, how about BC? Let's try BC, because when I'm looking at B and C, I see this row column, that column matches that row. So if I try BC, B is that 3 by 2, and C is a 2 by 2. These match, so it looks like it's going to work. So BC is going to work. And then what else here? What else? Well, look, I got a, okay, look at C and A. Row, column, row, column, row, column. So this column matches that number of rows. Let's write it and be sure that it's going to work for us. So if we try CA, C is that 2 by 2, and A is a 2 by 4. Those two match, so this is going to work. And I think that's the only ones that are going to work. That's all I can see. Let's perform this multiplication in 11. So what we have here, first of all, we've got a 2 by 2 multiplied by a 2 by 3. So it is these two matrices are compatible. And we're going to end up with a 2 by 3. Let's see what we get. So to do this, we're going to cross, okay, here we are in row 1, column 1. So we're going to use row 1, column 1. Row 1, column 1, we're going to go component-wise. First and first, second and second. And here's what it looks like. First and first, 5 times 3 plus, okay, second times second. That's going to be a negative 1 times that 0. Then we're going to go with this element, first row, second column. So we're going to use first row, second column. So first and first, second and second. So it's going to look like this. 5 times 5, there's first and first. And now second and second, we'll get a plus negative 1 times 1. And then over here, we're in row 1, column 3. So I'm going to use row 1, column 3. So first and first, second and second. So first and first, there's a 5 and a negative 2, plus second and second, negative 1, and that 4. All right, so let's get these others. So this down here is row 2, column 1. So I'm going to use row 2, column 1. First and first, second and second. So it'll look like 3 times 3 plus 0 times 0. Then, right here, we're in the second row, second column. So I'll use the second row, second column. First and first, second and second. So first and first gives us 3 times 5 plus 0 times 1. And then finally, in this position here, we have, where are we? We're in second row, third column. So second row, third column, we're going to use the second row, third column. Second row, third column, and I use first and first, second and second. So first and first, that's going to look like 3 times negative 2 plus 0 times 4, second and second. So simplifying, we'll get in the top left, we'll get 15 plus 0, so we'll get a 15. Over here, we'll get, over here, right? We'll get 25 minus 1, that looks like a 24. And then here, we'll get negative 10 minus 4, negative 14. And then down here, we'll get a 9 plus 0 is 9. And 15 plus 0 is 15. And then, finally, negative 6 and 0 is negative 6. And I think, if all the arithmetic is correct, that should be our matrix. All right, now I'm not really going to do number 12 here. Number 12, you're going to have to put this matrix A into your calculator. So put that in as what? It is a 3 by 3. And then go get matrix A, just second matrix, choose number 1, A, and then right on top of that matrix key, not second matrix, but just press the matrix key there, you get the negative 1, and that's going to give you the inverse. And here in 13, we've got two stores that sell the exact same brand and style of a dresser, nightstand, and bookcase. So matrix A gives the retail price in dollars of each item. All right, so I'm going to list these down. So what we have here is we have dressers, nightstand, bookcases, and these are the prices. So this is, I'm going to put the price here. $250 for a dresser, $80 for a nightstand, and $60 for that bookcase. That's matrix A. And matrix B, this gives us the number of items each store sells. So we're going to have store 1 and store 2. And then they are selling dressers, nightstands, bookcases. And store 1, I'll just go down the first column here. They sell 40 dressers, 30 nightstands, 50 bookcases. And then store 2 sells 35 dressers, 35 nightstands, and 75 bookcases. Now we could do this on our calculator. You might just want to do that, but I'll do it here just to get an idea of what's going on. So when we make this multiplication, well, first of all, can we do it? Look at this. This is okay, let me start that again. What size is this actually? This is a 1 by 3, and B is a 3 by 2. Two middle numbers are equal, so it's compatible, and we're going to end up with a 1 by 2. So let's see what we have now. So we'll make our multiplication. So it's going to be, right, first row, first column. So it's going to be first and first, plus second and second, plus third and third. So let's do this. It is going to be $250 times 40 dressers, plus $80 times 30 nightstands, plus $60 times 50 bookcases. And then we will have, okay, now this is going to be this row and the second column, right? We're in the first row, second column. So let's keep going here. We're going to have, okay, first and first, second and second, third and third. Let's see what we get. We're going to get $250 times 35 dressers, plus $80 times 35 nightstands, plus $60 times 75 bookcases. All right, and when I add these, multiply and add, here's what I got. Now it's dollars because this is going to give us the total number of dollars sold in each store, 15,400. And then the second one is 16,050. So store 1 sold $15,400 worth of these products, right? Dressers, nightstands, and bookcases. And store 2 sold $16,050 worth of those products.